Hello. This is a tutorial on visibility expressions, and this is a small level I have made as a tutorial to visibility expressions. So I have a lot of different visibility expressions here going up an ascending tower, which will show different things. So in this tutorial, I will show you things such as the all command, the any command, and the count command. I will show you how to combine auto-solve areas with panels, with visibility expressions. And I'll give you a general overview of what you can use it for. So, I have everything solved already. So right now, I have a visibility expression on the store instead of its normal animation, and in fact, I've disabled the store from animating in the normal way. So right now, I have it to be visible whenever this panel is not solved. So visibility expressions visibility status has to do with it checks the conditions that it has, and if those conditions are true, then the thing is visible. So if I want things to disappear, I have to put a not there. In this case, instead of saying on panel 1, I have to say not a panel 1. So now let's undo this. So on these three panels, on the visibility expression that is reading from these three panels, I have it so that only when I solve all three of these does the visibility expression actually appear. And you'll notice these panels appeared as well. So this is a sniping setup. So they're actually gone. They're not just invisible. You can see I did not solve this panel, had no chance of ever solving it. These next ones are set up on any. If any of the panels in this group are solved, then they will solve. And these panels are non-saving, which is why they're not making a thing by default. So if any of these panels are solved, I get it. I could also do that with count is equal to 1. I'll show you that later. And these ones, I have count is equal to 2. So this will show when count is equal to 2. Any two of the panels. So if I want to say that you only have to solve 10 panels in a group for something to appear, here's how you would do it. And now I have this set up to an auto-solve area. So this panel solves and unsolves as I come close to it, and this appears and disappears as I come close to it. I also have a door over there in the distance that appeared while I was doing visibility expressions. So that's how you might introduce some kind of progression using visibility expressions or some kind of hidden changes to the world. Now, what was I saying about this? The reason I started with a door is because you can actually think of visibility expressions as being instant doors. So doors move everything that's attached to them, and visibility expressions invisible everything that's attached to them. You can think of visibility expressions as being door animations where the door does not need to come from anywhere and it does not need an animation. So let's back out of this and let's go into all my visibility expressions that are affecting different things. So if I click on this door, you'll see the visibility expression that I used, and you'll see it's not panels 0. So this is a Boolean statement, and I'm basically saying so the exclamation mark here is the part that says not. Whatever follows, it is now going to reverse the truth statement of that. I need to back up for a second. A Boolean expression is an expression that evaluates to true or false. In this case, my panel is true if it is solved and false otherwise. So by looking at panel 0, I'm looking at the first entry to panels here, which is panels entry room panel high. So that is this panel right here. So I'm saying look at this panel and then be visible whenever it is not solved. And when that door is invisible, then that's when I can walk through it. So there are also some handy functions that are included in VisX, which are not normally not always there. So let's look at visibility expression 2, which is looking at these three panels here, and it's saying all from panels. So whenever I look at the panels group, it's saying, hey, I want all of these to be true before you can go through. And that's just a shorthand for what you would type in otherwise would be panel 0 and panels 1 and panels 2, etc., etc. So and is your is the and operator here, where everything needs to evaluate to true before the and operator will evaluate to true. Likewise, I also have the or operator, which is this one. And this is the logical OR, which means that any of these can be true, and this will be true. And multiple of these can be true, and this will be true. As long as at least one of the things between OR statements is true, it will evaluate to true. So I might ask you in real life, would you like a glass of milk or a glass of orange juice? You would answer either milk or orange juice. In this case, if you're evaluating it in Boolean logic, if you wanted either of those two things, or both, you would say yes, instead of answering which one you wanted. Because this is a logical OR, it cares about true and false values. It doesn't care about milk or orange juice. All right. So all is shorthand for all of them, and any is likewise shorthand. So if all is shorthand for panels and panel 2 and panel 3, then any is a shorthand for panel 0 or panel 1 or panel 2. And if we go up to the next layer, which is now looking at these guys, I have count of panels is equal to. So I can actually use is less than 2, and now it'll be visible as long as I haven't solved 2 or more. I can say more than 2, and now it's visible as long as I have 2 or more. What I set it to is equals to. I need the second equals here. A single equal in programming means assignment, so I would say set the count of the panels to 2. I need to put equals so that it knows I want the comparison of the equals instead. So equals 2, as long as I have exactly 2 panels, no matter how many I had here, it would work. Of course, if I wanted to be more understandable, I could say more than equals 2 rather than more than 2. So more than equals 2 as long as I have 2 or more, and less than equals 2, same difference. So this count just provides an actual number of panels that have been solved, and then it compares to the right-hand side. If I really wanted to, then I could do something like count groups 1 and count groups 2. And I could say as long as you have solved more of group 2 than group 1, it's visible. So auto-solve areas and visibility expressions really work well together. So I have an auto-solve area here, and what it does, when I enter it, it solves this panel, and when I exit it, it unsolves this panel. I don't have to unsolve it when I exit. I could just make things permanently visible whenever I walk through this area, or I could always unsolve something and make sure that it's, whenever I walk through this, something becomes invisible. This is a similar trick to what Kiwi pulled in Code 2 with the glass tank room, for those of you who have played. Whenever you enter a certain room, a scene in the other room becomes visible, and that scene is your clues for the puzzle in front of you. Sorry, Kiwi, I'm spoiling Code 2. So auto-solve areas mean that I don't even need this panel to be visible. This panel can be at like negative. Nope, that's not the transform. This panel could be at -1000, not even visible, and it would still work. So let's resolve hi here. Yeah, you popped back in. I need to resolve these. None of these are under saving panels, so none of these are going to save. And now this panel's not here. This auto-solve area still solves it. So, and I set it to never unsolve. So now this little whatever the fuck I drew here is always going to be on. So that's your brief introduction to visibility expressions. There is a lot you can do with them. I should show you how to actually add them to stuff. So if I just look for viz in the filter here, I can see node visibility expression. So what I have here is it has been parented to this. So let's actually look at this first grid map. This is my main grid map. Let's say I want that to become invisible sometimes. And I want it to become visible only when panels 0 is solved. And panel 0 is going to be my basic high panel, which is, where's my panels? Right here. So now let's go into the map. And because this is... I think I made a mistake, because this should be modifying whether or not the entire thing is there. Let's see what mistake I made. Let's see if we can sniff it out. I put panel 0 in the editor description instead of in the expression, so the default expression is just false. Now I have it at panel 0. And now, let's wait for you to load in. Now, it's visible. When I say no, it's not visible. So this is a little bit of a silly thing to do. but, you know, demonstration purposes. So visibility expression changes the visibility of its parent, and the parent will therefore change the visibility of all of its children. So the way that I get these panels to appear here is because I have a visibility expression that is affecting them. So grid map 2 is, if I make this invisible, it is this piece of gray, but it's also everything below it. So if I make this invisible, all of these panels are also going to be invisible. I could also make a separate visibility expression that it has the same panels and has the same expression, and put those under each of these. So for example, if I wanted panel high 5 to save, then I would need to put a duplicate visibility expression under it and put it under the saved, under where panels save. So, you know, there's some little bit of inconvenience there. Not that big a deal, because I can just duplicate and immediately have something which has all the same data. So, there is, however, a caveat to the fact that all the children will will disappear as well. Node, for example, is not a type of node that has visibility, so it won't pass that down to any of the children. So right now, if I make grid map invisible, this one, which I just put under its own thing, is still visible. So you have to be careful that everything you want to disappear is actually under a series of nodes that all have the visibility and transformation properties. Because visibility expression doesn't just make something invisible, otherwise you could still solve the panels, it also basically makes them as small as a knot and teleports them off to nowhere. Okay, so you need to make sure that you have something like spatial, or something that, change node type, where's change type, something like spatial. So anything that derives from spatial has a transformation and it has visibility. So now if I make this grid map invisible, this goes with it, and it'll go with it in visibility expressions as well. Auto-solve areas, since I have introduced them, they're very, very simple. You place down, can I click on it? There we go. You place down an auto-solve area. As soon as you enter it, stuff happens. And actually, I will show you something. This auto-solve area is under a grid map that has a visibility expression. So until that visibility expression is triggered, this isn't going to do anything. So I'm just going to place this down here. Yeah, intersecting with the ground. And then I'm going to unsolve on exit, and I'm going to unsolve the same panel high 12. Where is that? That is here. So I need to unsolve it because I currently don't have that panel there, and it's just going to always be solved when I come in right now. All right. So you're still loading in, but I'm ascending the tower so that I can. So I have it under the same visibility expression as this that just appeared here. And, you know, the auto-solve tutorial is no longer here, so it's no longer going to happen. But as soon as I go here, this plane starts to exist. Now, if I go up here and I do something that causes the visibility expression to now be false, if I wander over here, the plane no longer pops in because the auto-solve area, even though it's not visible, has still been shrunken down and teleported. So I can use VisX areas to enable auto-solve areas that enable VisX that enable visibility expressions, and thus creating a very complicated chain of logic. And because VisX visibility expressions allow for arbitrary Boolean logic based on panels, I can do some extremely complicated things without having to touch scripts myself. I prefer to touch scripts myself. A lot of you are not familiar with scripting, especially not in Godot. So this might be something you can look into for implementing some of the complicated sequences that you're imagining. So this has been your introduction to VisXs.